Thank you, Julian, for your presentation, and I'm going to start. A German scientist from 18th century, Johann Wolfgang Goethe, said, "You can only see what you know." I like the interpretation much more. You can only see what you know and what you understood. Why it is so important for product security today? Because you can only monitor and protect what you know. Otherwise, your results will be either not correct or insufficient. Bosch Product Vulnerability Incident Response Team, responsible for chassis system control and cross-domain computing solutions, is responsible for vulnerability monitoring and security testing. Therefore, we continuously looking for the new available solutions on the market for security testing and vulnerability monitoring. In my free time, I'm co-organizing ISRG meetups. ISRG stands for Automotive Security Researcher Group. On one of these meetings, I met a person from Cybellum who explained me something about a startup and also developed a solution. We did some meetings with Cybellum and decided to do a proof of concept to evaluate potential benefits of this solution for Bosch, check if this solution could be integrated in existing infrastructure and existing tool chains. We divided our proof of concept in two parts. First part we called POC, and the purpose was to see the tool and functionality on the example firmware provided by Cybellum. The second part we called proof of validation, where we installed the tool in Bosch own environment and test the real Bosch product. Who already tried to get an on-premise solution in a corporate network environment running, you know that this is the first challenge you need to solve. It is about to be confirmed with all existing internal rules using a third party and at the moment unknown application. It is similar when you bake a cake and want to put a new, not known ingredient. You don't know if the result will be good or not. However, thanks to the great support from Bosch internal team and Cybellum supporting team, we solved this problem quickly. The next step was to test a real product, and we did it. I know that this is the most interesting part here. Unfortunately, I cannot share the detailed results here. The results are only available in Bosch internally and strongly regarding need-to-know principle. Yes, we are security team. Therefore, we will focus during this presentation on the Cybellum solution itself, present the concept, functions, and benefits. However, to show you practical aspect of the POC, we decided that Cybellum will do a demo and present results on a Cybellum demonstrator automotive component. Surely, the Cybellum team can present Cybellum solution better than me, and therefore I have here Thomas from Cybellum with me, who will present their solution, and Eyal, also from Cybellum, who will do the demo. And as Julian already said, after this presentation, we will try to answer your questions. Thomas, the stage is yours, and I'm very excited about your part.
Thank you, Dirk. Thanks for the introduction, and thanks for the opportunity to participate in this event. Let me share just quick. There we go. As Dirk mentioned, we split our part into two elements, basically. So I will talk a little bit about the concept, about what we do as Cybellum, and then Eyal, my colleague, he will show you basically on a live environment how the platform works. So, but first of all, what are we doing? So we as Cybellum, we enable our customers in the automotive industry to develop their products securely, specifically in the terms of vulnerability management of ECUs. There's a concept of the digital twins which we have adopted, and based on that concept, we built our platform. However, first of all, let's start with a quick situation update, basically. So when we look at the car, the modern car, compared to a car not long ago, just a few years ago, from a ECU perspective, basically from the compute that is inside the car, then we easily see that things have changed dramatically. A few years ago, we didn't have big sat-nav screens, sometimes even bigger than your smartphone or your tablet computer. And those ECUs these days are rich in terms of functionality, connectivity to the outside world. And when there is connectivity to the internet, there's a potential security risk involved. And due to that, there's, of course, regulation coming in these days. For example, WP29 and ISO 21434. So if you're a car manufacturer or a tier 1 and you want to bring a new product, a new car on the road, you have to take those hurdles. You have to prove that you have developed your product from the very beginning, not just secure in terms of car security, but also in terms of cybersecurity. And that's where we come in. So what exactly do we do? As mentioned, we enable our clients from the automotive space to securely develop their components, their connected devices, from various standpoints. At the beginning, during the design and development phase, of course, it is important to have an understanding about the situation of the assets in terms of vulnerabilities. But we discussed briefly the situation with upcoming and existing regulations, standards, and their own compliance from an organization that companies need to fulfill. But we as Cybellum, we look at the whole life cycle of the product. So it's not just the development phase, but also when the product is out there in the market. So then it is really important to being able to have an understanding what situation are those devices in and where is an incident, and being able to respond as quickly as possible during a enabled basically due to a continuous monitoring. The concept we use to build our platform is based on a concept roughly 20 years old in existence. We took it and developed it further into the cyber world. So we call it the Cyber Digital Twin Platform. And what it does, we take the firmware from an ECU, the software, the binary file, and through our platform, we create an identical replica. So we have an understanding of all the components of that specific device from a software perspective, as well from a hardware perspective. We create an SBOM and an HBOM, bill of material, and we have an understanding how the connectivity of that specific device is looking like. And that enables us to run it against certain databases for CVEs, CWEs, but it doesn't stop there. So it's also that in our platform, there's an engine specifically designed to work on 0 days, to discover potential 0 days inside the software. So how does it look like? the customer is operating the system through various dashboards, and they are differentiated into two components. First, there's a product security assessment element that's really focusing on the design and development phase, providing from the very beginning transparency and enables an understanding of the compliance situation, whether or not there are validations and how to overcome them through specific recommendations, and as well provide the same transparency in terms of what vulnerabilities does the firmware actually have. Of course, software is kind of a living element, and therefore it develops over time with new versions. And through typically the PLM system of our clients, the platform is automatically updated with new versions of an ECU. And against those versions, the platform works then again and delivers the same results for each new version. And that basically brings us to the second element, the post-production element called product security operations. So during the whole life cycle of the product, once it's launched, we provide a continuous monitoring of potential threats. And when you think of, for example, a car manufacturer, which is having dozens of models out there, each model contains dozens, if not almost hundreds of ECUs and software components, it's a real challenge to have an understanding when there is a threat, when there is a vulnerability, which ECU is affected, and what is the impact of it, what is the risk. So our platform really does all that. It creates a risk score, it prioritizes, and really enables our customers to focus on the tasks, on the critical tasks that need to be, worked on in a short amount of time in order to keep the ECU, to keep the car secure. And that really helps our clients with reducing workloads and increase the team's agility. And with that said, I would like to hand it over to my colleague to give you a little bit of an insight into our system. Eyal?
Yes, thank you, Thomas, for the great introduction to our platform. So hi, everyone. My name is Eyal Treitel. I'm VP Product Management at Cybellum. I would like to show you the Cyber Digital Twin platform. And let me start with... basically, what you see here is our core part of the product, the Cyber Digital Twin screen. This is our capability of asset management of the system, the ability to track components and provide software exposure of these components. You can see that we have samples here of many ECUs of a vehicle, ADAS systems, gateway systems, infotainment systems, and so on, which are representing the rich operating systems type of components, ones that are based on Linux and Android, automotive grade Linux and the like. But we can also cover components which are microcontroller based, like engine controller units and so on, based on Renesas and Tri-Core architectures, as well as mobile applications, key fobs, and so on. So there's a wide coverage of architectures and operating systems. And one of the benefits of digital twins is the normalization of data. So a software exposure, the same details, obviously for each platform there would be differences, but you see all of the components in a standard fashion, no matter their type or architecture. And if you look at a Cyber Digital Twin, there are many, many aspects of the hardware and software that are covered, the software bill of materials, the licenses, many, many aspects of the component are covered, the ability to traverse the file system of the component and so on. But the value of a security solution obviously is not only in the exposure of information, but even more so in the assessments of the product. And we provide 3 types of assessments. Vulnerabilities is for publicly known vulnerabilities. This is the ability to track during development and also later on in post-production lifecycle phase, the publicly known vulnerabilities for a given software bill of materials for a given component. And we keep track of that over time and with the tracking and management capabilities. 0 days detection is the ability to perform a low-level, deep binary analysis of first-party or third-party code. This is providing the ability to detect issues which are not publicly known, as well as policies, which is a strong policy engine. I'll show you a little bit later. This is the ability to cover predefined or customized policies, standards, best practices as well. So how do you manage a large environment with many digital twins and many assessments? You'd like to have dashboards. I'm showing here just one of them covering governance type of information, starting with the operational risk. Because we have the assessments and we know a lot about the components and their risk posture, we can track of risk, the overall risk of a population of components, and also risk over time, how security changes as you remediate vulnerabilities, as you eliminate vulnerabilities over time, as assessments get software updates, and so on. There is ability to track ticketing as suppliers or OEMs or suppliers open tickets versus their suppliers the next years. There is an ability to track the tickets over time and how they apply to the SLA arranged towards the supplier. Of course, the progress of assessments over time as well. The ability to connect the Cybellum platform to asset management systems, which is another potential use of the system, enables a customer to basically map the real assets that are deployed and how they're impacted by security issues as they come in from the intelligence threats, intelligence feeds. The ability to track the progress of security risks versus the suppliers is another angle. Keeping track of the progress of how suppliers are fixing security problems for you is another angle. I'd like to show you a little bit of the compliance capability. The system provides already out of the box hundreds, if not thousands, of requirements that are covering different aspects of the digital twin, different aspects of the operating systems, of the code, configurations, and so on. These requirements can be configured into customized policies by the customer, or are provided as predefined policies that we provide tens of them, covering many, many standards, best practices, and regulations in the market, covering things like the WP29 and Annex 5B, MISRA, CERT-C, and the list goes on and on. Just to show you one of them, this is an assessment, a policy assessment for the WP29 Annex 5B, the threats table, with automated findings of issues detected in the cyber digital twin, detected in the assessments of the digital twin, showing how they map into the Annex 5B regulation. Of course, the system provides also the ability to produce offline reports of these audits as well for later use. So last but not least is the ability to take the system and integrate it with other capabilities. Here we demonstrate our integration into other platforms. The Cybellum platform does not live on its own. It is possible to configure that with many, many systems available in the customer environment, starting with ticketing systems like Jira or Asana, task-based task management systems. The ability to keep track of security issues and manage them in your existing platform for managing bugs and security tasks is a very important factor for many of our customers. There is a big trend in the market for automation, and that happens also in security, what is typically known as shift left of security operations. And many of our customers are implementing a CI/CD workflow where they take their software development lifecycle and put in the security assessments, the product security assessments as part of that workflow. Is mainly performed by integrating with the existing CI/CD and automation and DevOps platforms such as GitLab, Jenkins, Azure DevOps, and so on, where each software build, or at least some of them, are automatically being scanned and assessed by the platform and automatically evaluated by the Cybellum platform, and results are then managed by the product security team. We also have the ability to integrate with software over-the-air update systems such as Harman, OTA, and others. This provides an OEM the ability to validate at the last release point, just before a software update is released to vehicles, to put some validation on the software that goes into the vehicles. It's like a last checkpoint in the software update teams to do a security validation. And another angle that is possible for integration is product lifecycle management. We have an announced relationship with PTC, one of the leaders in the product lifecycle management sector. PTC Windchill is a software suite that lets customers manage the development and manufacturing of products. And one of the angles of the solution is testing. And this is where Cybellum fits in. We provide the security testing angle, where part of the lifecycle management of a component, of the development of the component, is to test its security as part of the overall lifecycle. And that complements the overall lifecycle activities done by the customer, really in an integrated method. So with that, I'd like to hand over back to you, Thomas.
Thank you, Eyal. Okay. Yeah, so to quickly sum it up again, I mean, of course, you have to keep in mind that this is just a little bit of insight of what we do. There's much more to share, but in a nutshell, the 2-3 main tasks we help with, based on the feedback from our customers, is A, meet compliance. It's a strong demand these days, considering the WP29 and ISO regulations, as well, of course, the reduced risk, as well as the decrease of manual labor that is involved with such tasks, because like highly qualified people, they should not, spend time on prioritizing CVEs for ECUs all day long, rather than work on real tasks that cannot be automated. Okay, so yeah, there are a couple of questions, and I think we should use the time to go through the Q&A session.
Maybe I'll take.
Maybe take it, or you want to take it?
Yes. So first question: are there certain components that have a higher vulnerability and therefore require more attention? That's a good question. Thank you. So we do see a big variance of the mixture of issues between different component types. So the rich operating system components, such as infotainment systems, telematic units, ADAS systems, they have large operating systems like Linux, where just the OS itself has a very big risk posture with hundreds, if not thousands, of vulnerabilities on a typical assessment, just on its own. And obviously, the OS comes with a lot of software components, and each one comes with risks. Going down to the microcontrollers, where typically there is no open source part, only third-party or first-party code or combination, and typically there would be very few vulnerabilities. Of course, each one might have a big impact because those components are typically critical in most cases. So there is a big variance. I hope that answers the question. Maybe I'll continue with the other ones. Is the customer able to adapt dashboards? Yes, I've only demonstrated some of the capabilities that we have. Typically, we work very closely with our customers on their specific needs. So some things are provided out of the box, some things may be customized depending on the specific needs. There's a question here: what is an example for a software issue that is not publicly known? So these would be things like, think of the third-party part of a code. Let's say it's an infotainment system. Many parts are software packages like the Linux, streaming media packages, browser packages, and so on. But some parts of the firmware are probably the customer unique applications, things that are developed by some company, either the supplier of that component himself, or maybe some other outside suppliers of software. Those typically don't get public representation. The vendors are not running around to publicize every issue they have. So nothing there is publicized, but these are still software code pieces that have issues. And these could be things like buffer overflows. These could be, code complexity issues. So many different kinds of weaknesses that could have been, they could have been publicly known vulnerabilities as well if someone would report them to the community. It just happens that the practice is not to publicize everything in the embedded software market. And last question I see here is: how is operational risk calculated? There are many factors that are taken into account, starting with the severity of issues, the component type, connectivity, and so on. So there are many things that can impact the operational risk. Don't forget that there's a lot of information we gather from the components, but also from the user. We have mapping of the component types. We know connectivity details and so on, and we can leverage that to calculate risk.
Perfect. Maybe looking at the chat section, there are two more questions. Maybe Dirk, you could answer one of them. From a point of view of Bosch, what were the key learnings from this project?
Yeah, thank you for the question. It is a great question. And so we are working with vulnerability monitoring in our team for some years. And this project was not to learn anything new, but it was about efficiency. So if you take some components, well-known open source components like Linux kernel, Android, or some other very well-known open source components. And if this version is some month old and you put on any vulnerability management system or vulnerability monitoring system or performing CVE search. Now, not regarding any concrete product, this is the challenge. Current challenge is if you put this component and perform this CVE search, for example, not only for or in NVIDIA database, you will get hundreds or probably thousands results. But if you're evaluating these results, you will find this that a lot of the issues are false positives because it was only search based on the version number. But you need look this more deeper and analyze what is real affected or relevant vulnerabilities. And it is therefore it is such POCs how we can do efficiently. So one way, of course, you can do some traditional or classical tools and have enough people who are analyzing this. So then it is working, but how you can do automation. And this was exactly to see if any tools can automatically filter out all false positives, and then you can only focus on some few vulnerabilities, but that are relevant for you. I hope that does answer your question.
Perfect. That was really good. Yeah, go ahead, Thomas. Sorry.
Yeah, I just wanted to cover the question of Christoph. He's asking how open are suppliers to your solution and what are the concerns raised by them. So these days, the suppliers, or let's say OEMs and tier ones, are actively looking and engaging with us. That is, of course, driven by the regulations we discussed a little bit during the session, as well as the overall security situation of their devices. But clearly, regulation, standards, compliance is a big topic these days. And in terms of concerns, I mean, I'm not sure what specifically is meant with it, but yeah, concerns when it comes to implementing the solution, if that's the question, then it's, of course, we are talking about intellectual property. So the question always is, our solution cloud-based or on-prem? And in fact, you can choose. So our solution can be installed as a cloud-based installation, or if your organization prefers or have like some sort of security guidelines that makes it mandatory to have such a solution on-prem, that's no problem. We support both ways. I hope that answers the question.
Perfect. If there's some more questions, we have around 5 minutes. So maybe let's see, Q&A section. There's maybe one more. What about application outside of automotive? Maybe Thomas, you could answer that again.
Yeah, so our solution specifically is not limited to the automotive industry. I mean, there's high demand coming from that sector because of the reasons I just mentioned. But basically, we enable to really secure, develop, and maintain components. So you could think of the medical industry where we have projects. You could think of the energy sector. So everywhere where you have components out in the market that are connected to the internet and needs to be secured over the life cycle, we can support. Are there further questions? If not, I have one more thing to mention. For the automotive industry, we just have released a report. Our colleagues from the research department have analyzed around 100 automotive devices and have really compiled current status of the automotive software security. So if you're interested to have a look at that report, you can get in contact with us. The emails are up there, and feel free, and you can get the report from us. Thank you very much, guys, for having us. Real pleasure to be here. Thank you, Dirk, and have a great day.
Perfect. Thanks, guys. And there's more information in the chat in case you want to learn more about the project. There's the speaker profiles of all of Thomas, Ayel, and Dirk. And thanks for joining for today. And now there's still a little bit more time left for some networking, so feel free to join us on Hopin. But besides that, that's all from us. And I think we can leave it with that.
Thank you, guys. Have a good one.
Thank you, guys.
Thank you.
Bye.
Bye-bye.
Bye-bye.